Today I'm going to demonstrate an exercise I call Zen and the Art of TDD. The goal of this practice is to try to clear your mind of any preconceived notions about a solution, to force yourself into thinking about the simplest possible way that you could take the next step when test driving a project. Sometimes you get some funny results when you do this because you're not thinking ahead and you find yourself having to do a little backtrack. But the goal here is to train yourself mentally to be able to clear out those preconceived notions. And it's really handy when you get stuck because you are using your preconceived notions and you keep finding yourself not able to get through a step. So, of course, because we're doing test-driven development, we're going to follow Uncle Bob's 3 rules of TDD. We will write no production code except to pass a failing test. We will write only enough of a test to demonstrate a failure, and we will only write enough production code to pass that test. So we'll try to be very disciplined about these 3 rules, and we're going to try to not think way ahead about our solution. So I'm going to demonstrate this using the red pencil kata. Full disclosure, I have completed the red pencil kata before a number of times, so I do have previous experience with this problem. However, I'm going to work really hard to pretend like I don't. And that's really what we're trying to do here, is pretend like we don't. So to review the red pencil kata, in case you're not familiar with it, the idea is we're mimicking a real retail situation where things go on sale, and we have a set of rules around how those things go on sale. A sale is called a red pencil promotion, and the idea is that when there's a price reduction between 5 and 30%, it's considered a red pencil kata, or a red pencil sale, I'm sorry, if the previous price were stable for at least 30 days prior to that reduction. A red pencil promotion only lasts for 30 days. If a price is reduced further during the red pencil promotion, it remains a red pencil promotion, but it does not change the duration. So if on day 1 I reduce the price by 10%, that starts the timer for 30 days. Day 20 I reduce it another, say 5%. It's still within that 5 to 30% total reduction from the initial price. The duration of the remainder of the sale continues to just 10 more days, and then the red pencil is over. If the price of an item is increased during the red pencil promotion, the red pencil promotion ends. If the price is reduced during the red pencil promotion so that the overall reduction is greater than 30% with regard to the original price, then the promotion ends immediately. And after the red pencil promotion has ended, the additional red pencil promotion may follow. However, you must have a stable price for 30 days. So you can't end a red pencil on December 15th and start another one on the 20th. You're going to have to wait until 30 days later, so January 14th. So those are pretty straightforward instructions. I've put together a simple project in JetBrains Writer. And just to speed things up a little bit, I've already created the solution. I've created the project for testing and for the production code, and I've put a dummy test in here just to ensure that I can actually execute the tests. And so if I go here and run my tests, this will compile and run. It takes just a second, and whoopee, it works. So the next step is to say, all right, so how are we going to test the red pencil kata? So we're going to call it the red pencil sale test. Seems like a reasonable name that expresses what we want. Using X units, so we're going to declare a fact, public void something. So what is the simplest thing I can think of with respect to how this promotion thing works? And I think probably the simplest first thing I could do, starting kind of from the outside, is, well, what does the output look like? How can I determine the things that I'm going to need to determine for these assertions in general? And I think I would probably start with some sort of way of knowing whether or not an item was in fact on sale. So since red pencil is the exceptional condition, most things wouldn't be on sale. So some method returns not red pencil. And so then the question becomes, well, what is that method? What do I call to check that the state of the item is in or outside of red pencil? And so naively is red pencil not red pencil when not on sale. So that's sort of funny sounding, but that's okay. So we're going to assert false after calling is red pencil with, oops, autocomplete jumping in there. With an item. So let's just call that item. Well, let's make it a little more interesting. Let's say that we're buying I'm looking around my office for something to buy. Laptop. So is the laptop on a red pencil sale? Should return false. So now we need to figure out, well, what would we have executed? And the execution itself is really that is red pencil call. But is that a standalone static method somewhere? Maybe we'll start with that. And then we need a laptop. So what is laptop? Let's say item. Autocomplete and I are not having a nice time together. So I have a laptop. It's a new item. I don't really need to know its name. I just need to know whether or not it's on red pencil. And our basic rule is that if it's not on sale, then it's not original price, $1,200. We'll store that as a decimal, good currency type. And we'll see where we get with that. So let's create, I'm not even going to bother to create quote-unquote production code over in the production project just yet. I'm just going to create a class here called item. And item is going to have an original price member, and its data type will be decimal, and we need a constructor, and it should be public, that takes original price, and then we'll just set our original price equals original price, and autocorrect will be mean to us, and that's okay. So that takes care of creating, I think I've made a syntax error here. Or I've spelled something wrong. Yes, I've typed. I need another I in there. Original price is $1,200. And so we're almost compilable. We need some kind of a function called isRedPencil. So let's create a static method. It's going to have to be I'll just put it right here for now. isRedPencil. And that's Boolean. And it accepts at least one item. And so now I have something almost compilable. So we will return true. What the heck? So now run those tests. And it failed. And it failed for the right reason. We told it that we were expecting false. So what's the simplest amount of code that we can write to make this pass is to return false. We run again, and we pass. Okay, no real surprises there. Anybody with a little bit of experience in test-driven development in C# recognizes that as just getting the ball rolling. So, is red pencil when on sale? So now we're going to end up being forced to find out a way to determine that something is on sale. So let's say our laptop goes on sale. New item, original price, still $1,200. But let's say how explicit do we want to be here? So again, I'm working real hard to just think about what's the simplest thing I can do. I could construct this thing as on sale, but that makes my constructor, it's an optional parameter. I have things to think about. So I'm going to try to think of an easier thing, and I'm going to say laptop reduce price. Well, I could, instead of reduce price, I don't even have to do that. We could do new price. And we could make that new price, well, let's see, it's got to be at least 5% of our 1,200. So we just make we don't even need to worry right now about that 5%. Let's just make it a different price, and we'll make it lower. We'll say, okay, new price is $1,000, and then we expect this to return true. Now, obviously, when we run this, it's going to, oops, yes, it's not compilable. Not compilable. My bad there. That's no big deal. Public void new price decimal price. And somehow we're going to want to represent that the new price is new, but later, oh, wait, see, there's my failing to think it through. The simplest thing I could possibly do is change the original price. That'll make it compile. That's the smallest baby step I can take. So, build. Now run. Okay, now that failed, but we knew it was going to fail because we have put no logic in here. So how does my is red pencil on an item know that something is in fact on sale? And now we can ask the question, should is red pencil know this? Should is red pencil be part of item? And should item know that it's on a red pencil sale? So where does that business logic live? One argument is that an item is unaware of the condition of its sale price. Another way of thinking about it is that an item should be aware of its original price and every transient price and when that transient price was established. So we could, for the moment, ask this code to make a comparison. So we could say, let's try it just as this standalone method. An item original price is greater than items current price in items. Original price is greater than its current price. Autocorrect and I are really having a good day. We'll return true. Otherwise, we'll return false. Now, of course, we don't have a current price member, so that's going to cause us to come back here and do I'm a bit notorious for my typing errors. So now current price is set. And we should in fact have 2 passing tests, but we appear to have a typographic error somewhere causing us to, yes, we have an extra curly brace here. Okay, so now we should, looks like it's going to compile. Go ahead and run our tests. And look at that. It did not run when not on sale. Why did you not do that? Probably need to rebuild here. Doesn't see the new test. And then run again. Why are you not running that test? Here we go. Yes. So what mistake did we make? Ah, yes. Well, current price is not set at the time that we executed that test. So little assignment chain magic. Run it again. There we go. Now, we've written 2 tests. We were able to toggle back and forth between is on sale and is not on sale. However, we've made no assertions about the 5% or the 30%. So now we could say, for example, public void is red pencil, and I'm naming this so that is red pencil is the function name, right? Not red pencil when reduced less than 5%. And I'm picking on that just because that's one side of my conditional. So assert false is red pencil laptop item laptop equals new item original price 1200 laptop new price. Now I'm way too lazy to keep doing arithmetic in my head, so I'm going to say times 0.96, which will reduce the price by 4%. And I should get is false. Right, so this fails. I also have some spacing issues. Okay, and that's because it returned true when it shouldn't have. This is going to cause me then to go to my isRedPencil method and say, oh yeah, the difference between the original price and the current price actually needs to be based on this 5% notion. So if the original price is greater than the current price plus 5% of the original price, plus I know that I can rely on the order of operations, however, I'm not going to. So now, is it really greater than, or is it greater than or equal to? Well, for the decimal class, we should be okay here. Good enough precision. So we'll run it again. And now our test passes. So we've now covered just one side boundary. There's some cleanup we could do here, though. For example, our laptop. We keep using the same laptop, which is probably fine. We can just make laptop into sorry, not read only, just const. Except it's not compile time, so well, we'll just make it a member. That's fine. And that should run. We'll double check that we haven't made any syntax errors. We do have a bad habit of making those kinds of errors. And so now we've simplified these tests a little bit. And we'll run everything. Yes, we're still green. Terrific. Now, these constants here, they're a little annoying. So let's do some constant magic. I believe we can refactor this. Introduce field. Replace one occurrence. And let's original laptop price. Introduce constant, hit next, and that'll place that up here at the top of our class. Then where we have this, we can original laptop price, just to clean things up a little bit. Not a whole lot, just a little bit. Okay, so now what's the next simplest thing? Because we've tested that, we could just go back and modify our on sale to say, let's use 5% here. So let's do that. Original laptop price times 0.095. Oh my. Yes, that worked. I'm sorry. Yes. 9.5. For a moment I thought I'd made a terrible error, but no. This now should still be on sale. And it is. Now, we could even change the name of this to when reduced by 5%, just to keep the names a little more meaningful. To be rigorous, I will run that test, make sure that I'm following my nanocycle. All right, never refactor on red, red-green refactor. Public void is red pencil, when reduced by less than 30%. And we'll use, 29% in this case. So laptop, new price, original laptop price times 0.71, which is right there at the south end of the cusp. 70% would be 30, yeah. Need a little type identifier there to make the math work, and then assert new price is red pencil laptop. I'm sorry, it's not assert new price. Assert true is red pencil. And then I picked up some parentheses in here just because I like my parentheses. Okay. So we'll run again. And we're back to that doggone compiler issue. Build the world. Writer likes to be stubborn about what it's running. I'll go ahead. Oh, well, that's interesting. How did we break that one? When reduced by 5%. Maybe a little too much precision. Now, what bothers me is that I ran that before and it passed, which means I must be using my tool wrong. So I'm going to do this. I'm going to comment that out, hit save, rebuild the world, rerun, and now it's failing. Okay, well, at least it's consistent. It's failing. So I've reduced this price by 5%. Original price times 0.95. So then I check here and I say the original price, the current item price. So I suspect that those are exactly equal. That is probably the error in my thinking. That seems to be. Let's do a rebuild and a rerun again just to be 100% sure that we aren't getting tricked by the tool. Okay, great. So, it's totally acceptable, of course, that you make these kinds of mistakes. Especially when you're really focusing on not thinking too far ahead. You're intentionally not trying to think through those little subtle problems. There's nothing wrong with thinking through those problems, but our goal is to try not to. Let them come as they do. Focus on just the one thing at a time. Okay, we have 4 passing tests. Terrific. Now, our next test should be the other side of that 30% boundary. So, public void is red pencil, not red pencil, sorry. Reduced by more than 30%. Just occurred to me that this test should probably be at 30%. So let's back up a second. 30% would still be red pencil. At most 30%. So that should really be 30% on the nose. And it still passes. Certainly expected it to because we haven't even added conditionals for the other side yet. But baby steps and try to be conscientious about it, right? Is false, is red pencil, laptop, and laptop. New price original laptop price times 0.69. It's going to be a 31% reduction in the price. And go back to our unit tests, run them. Run them. Okay, now that one failed, but we kind of expected that one to fail because we haven't created this boundary condition. So now we go back and we look at our ZenPencil method and we say, okay, so an item's original price is greater than or equal to an item's current price plus 5% times its original price. And now we need the other side of that. It's also on sale if let's see, this would be an AND condition. And an item's original price is greater than or equal to an item's current price plus 30%. Now we're in trouble. We can't AND these things together because the price can't be two things at once. Greater than or equal to, greater than equal to. Actually, this may work just fine. Yeah, okay, so we can AND that. We can say the current price plus this is greater than or equal to the original price, and the current price plus this is greater than or original. This should work. It's not pretty code, and I'm not too worried about it being pretty code just yet. I want to make sure it works. Once I know it works, then I can make it pretty code. Let's see, what did we break? Yeah, this was the AND getting in our way. I think I was right when I said I think the AND is going to get into our trouble. Get us into trouble. So, compile, run them all. Now we should just have the one that fails reduced by more than 30%. So if I multiply by 69, I am now more than 30%. But I've taken the logic out. I would think it would pass because that would be 31% times the original price plus the current price is greater than the original price. Did I forget a step? No. The important thing to note here is that it was a very simple step. I knew exactly what broke the code. So I just took it out. So now I run those tests. I say, okay. Now, when I started, I made a choice about is ZenPencil returns true or false. So I have no idea, other than by stepping through it by hand, what the arithmetic is here that's going on that's causing the problem. And because I'm using floating point numbers, there is the possibility that equality is determined erroneously, but in this case, it shouldn't be a problem. This math here is 1200 times 0.69 is equal to something. Considering my inability to do basic spelling, I also don't trust my ability to do math. So times 0.69 should be $828. So I've set the price to $828. Now, if I go up here and I say 1,200 greater than or equal to $828 plus $0.05 times 1,200 $828 plus 60 $1,200 is in fact greater than or equal to $888. Therefore, we should be returning red pencil true. Have we written the assertion incorrectly? No. Is red pencil should not return red pencil when reduced by more than 30%. This is returning true because that is true and we don't expect it to be true. We don't expect it to be true because if the conditional were in here, this should tell us no. So let's change the way that we do the calculation just a little bit to make ourselves pass. Well, because we are now writing the code to make this pass. So we're not out of the red-green refactor. We've just simply made a bad choice. So alternatively, we could say if an item original price is greater than an item current price plus 30% of an item's original price. I think I see my problem. If it is greater than that, it is not a red pencil kata. Need an M in here. It's not red pencil, which is what we want. So I think I just got tangled around the details of the logic, but you know, that happens to everybody. Okay, now here's our less than 30%. And he's failing. So we'll take our comments back out of here. We don't need those anymore. For consistency, I'm going to put these back in. Just we do love our curly braces. So now, our 30% test is failing. So here, our new price is the original price times 70%, which is 30% off, which is going to be precisely equal to this, should it not? And again, we'll do some math. 1200 is greater than or equal to. I probably have the greater than or equal to backwards. That's what I usually end up finding out, is that I've not thought that through correctly. Current price, which is 1200 times 0.70 plus 30 times 1200 . So it's right on the nose. If I take that out, will it pass? Aha, they all pass. Okay. So now, because I don't trust it, because I feel like I've made a mistake, really struggling to not overthink this, I need to do let's see, so 30%, so let's do 29%. Don't really need to make this a separate test, but I can. And so now laptop, new price, original laptop price, 0.71 is 29%. Should be on red pencil. Okay, let's give that a try. And that passes. So we're probably okay. Should we try 31%? We'll just change this to non-red pencil. The goal here is to convince ourselves. Well, we've already got one of those, so I think we're okay. So we'll just take that out. We don't really need to keep that test. It doesn't help us because we figured out what we've done wrong, and our later reader can rely on us. Okay. So the red pencil promotion for one aspect of the first requirement, you know, just a half of that first requirement is doing its job correctly. And that's good, right? So now let's take, we're all green. We'll compile again and run again, even though I think I only removed comments, but just to be sure. We're all green. So now, is there something we can do with this logic to make life better? Can we improve its readability? For example, we could maybe combine, well, we could reduce these things. So first off, we could look at this and we could say, wow, That's kind of hard to read. So what if we extract that method? What would we call it? We may want to make a different choice first. So right now, is ZenPencil is part of our test code, which is, in the long run, not the game we want to play. So let's go ahead and make a choice here. Let's make the choice that is ZenPencil is notionally understood by the fact that the item knows whether or not it's on ZenPencil sale. Modeling that, if somebody wrote on me with a red pencil, I'd know I was on a ZenPencil sale. Fair? Okay, let's try that. So let's move this method. The first thing to do is to do that. And then I've got to be really careful about how I do this. So fix the visibility. Public is just fine for our little example. And I'm well aware of the fact that I am asking a question of the object to which I am passing. We're going to fix that second, but first, let's just make sure that everything compiles nice and happy. Old Bob Ross moment. Happy trees. And run those unit tests. Joyful, joyful. Now we can just go back here and say, since I'm talking about myself, I can remove the argument. And here I can say an item dot and replace that with nothing. Then selection replace all. And now go find every call and just remove the argument to laptop. And compile. And run. Now we've made that decision and we're not stuck with it, but for the moment it's fine. We can start messing around in here and say, well, if the original price is between these two prices, is essentially what we said. So we could extract this portion here into a local variable that says, we'll call it upper bound for now. And we'll extract this one. Bar lower. And we'll calculate both of those up front. And then we'll say if the original price is greater than the upper bound and less than the lower bound, then we return false, otherwise we return true. I think this will work. I guess those are really non-option things, but we'll go ahead and we'll run one more time just to make sure we didn't break anything in that extract. So if the original price there and that should still pass. Oh, see, we broke something. Okay. original price is greater than the upper bound, return false. If the original price is greater than or equal to the lower bound, return true. So, the original price is maybe that was just an or. Original price is greater than the upper bound, or original price is less than the lower bound. May have ended where I should have ordered. Oh, there you go. Should have ordered. Now, because we're asking the or here, we should, in theory, be able to change this to true and remove this. And things should still pass. Look at that. So, let's see, is there anything else that's really easily obvious that we should change? Probably for now we're okay. So now we can move on to the time component of that first rule. So that first rule said a red pencil promotion starts due to a price reduction. But it has to be between 5 and 30%, and the previous price must have been stable or unchanged for at least 30 days. So now we could say, well, all right, how do I know that the previous price was stable for 30 days? So I can just go ahead and move on to the next part of that first statement. Stable and unchanged for 30 days. So if I knew, for example, that I'm going to commit this code real fast. Just going to stick it in source control. That way, if I botch this really badly, I can step back and have this ready to go. What other things? You're telling me I can make that read only? That's fine. So what if we captured some other little cleanups in here? So the compiler is telling me that the precedence here is fine. Go ahead and run that. Get those little squigglies out of the way. I was so not thinking about it, I didn't even see that refactor. Look at that. Ooh, much cleaner code. Well, maybe. I guess it's a style thing. For me, that's okay. I like that kind of code. You may think that that is too dense. And apparently these things could have been, well, that's just we haven't used any of them directly at this time. So we'll go ahead and we'll take the public modifier off of there. If we need to put it back, we'll put it back. We'll even props. At that point, it's sort of silly to make them props, but whatever.